this Olympiad workshop held by Raising a Mathematician. I hope you enjoyed your Saturday yesterday, the classes that we had, and I'm quite excited about today. Hope you have fun. Today we have, um, before we start, if you have a good enough internet, please switch on your camera so we can see you. I see that some of you already have. Wonderful to see you all. Okay, so today we'll be starting off with some exciting geometry by Bhas Bhamre sir. Sir, are you there?
Yeah, yes. Am I audible
Okay,
properly?
you're
Yeah.
properly audible, yes.
So should I start?
Yes, you can start.
Hi, good afternoon, everyone. My video is off. Just for a while, I will make it on. Okay, so this is me, maybe visible. Okay, but my light is against. So today we are going to just have a small fun with geometry. And after that, uh, in future, that in coming year, then we will be continuously having the fun. So yeah, I put off my video because of the proper streaming. Yes, so here I would like to share something with you, and then we will go ahead. Okay, so here we have uh, this is the introduction to Mathematical Olympiad training program, because it is an start. This is the first thing that you are going to be here. Uh, I wonder if somebody already have joined the last year's IMOTP. This, if you have joined, then you will be aiming this AMOTP. So I included, but I wonder whether all are there or not like this. So I try my level best to go with some small things which are which will happen first of all, and then we will see some questions. I can't guarantee that everyone is acquainted with the concept, but we will see how we can think. So this is the IMOTP geometry. What we mean here, IMOTP means Intermediate Mathematical Olympiad Training Program. In that, we firstly aim to solve the problems like IOQM and RMO, but without any theory, we can't go ahead. So first of all, we go parallel with the theory. Okay. So it is not that only we will solve the problems. There will be theoretical background, and will be some assignments or prescribed books which would be used as assignments. And then we step by step go ahead. This course is also useful for NMTC. Many of you might have appeared NMTC final level this year, which happened on 25th October 2025. So you know the level or difficulty level of the questions. So that is also parallel with IOQM or RMO. So it is also useful for NMTC preparation. And here we expect some prerequisites. Prerequisites, that is what you must know, irrespective of your grade in which you are. Okay. So school geometry till grade 9th. Here we mean school geometry, that is what the angle, types of angles, pairs of angles, and triangles congruence. At least we know this. But in our course, we go with some small details of these terms: lines, angle, pairs of angles, and step by step we go ahead. Our main aim is IOQM and RMO. And because of that, many of your school level competitive exams topics will get covered. But the difficulty level of IOQM and RMO is the topmost. Therefore, if you are aware of such problems, then the diluted problem than them would be properly solvable by you. But here it is necessary to have the consistency and perseverance, which is very important, because if you are solving the problem and the solution is not coming, or you are not getting any idea from where to start, then usually we give up. But we mean here that we never have to give up. It's okay. Now, suppose I am not able to solve the problem. I may leave the problem for a while. I can change my mood, or I will shuffle my attention towards something different. And after that, say after some days also, I may recollect the problem, or I will keep that problem in my mind. And while just say taking breakfast or having lunch, or suppose you are traveling from auto and all, then also you can think on the question. So that perseverance, that again consistency is very, very needed. And basically we solve some numericals. Okay, we solve some numerical problems and proof based questions. Because in IOQM, even if we have numerical problems, those numerical problems are possible only when we are good at theory. Very rare questions in IOQM are solvable by some trial and error method. Or if you want to do that, then the time will be insufficient. I consider you know what kind of IOQM is. And then therefore, 30 questions and 3 hours time you find insufficient. Our aim of this IMOTP is basically to uh, give the atmosphere to all the participants, like to solve the Olympiad problems, NMTC kind of questions, or also I can add over here AMC kind of problems, so that in future, if you want to develop you by giving some standard examinations, you can. Okay. And moreover, the next level, that after IMOTP, we bring students to advanced mathematical Olympiad training program, in which in geometry, we prepare for RMO and mostly INMO kind of problems. There are many results or theorems. Here I used one name lemma. Actually, what is meaning of lemma would be a question in your mind. And because of the technology, you can immediately find out. So I'm not going in detail. So here we learn some results in geometry and bring students to some next technique to solve the problems. So it is very important that solving problems using different tools and techniques, that is very important. And these geometric configurations are quite essential, because if you know the geometric configuration, you can easily find the application of configuration in the problem. But there are hundreds of constructions, hundreds of configurations, right from basic to higher level. We do step by step. Okay. Yes. I would like to put your question in the chat. So whatever the problem you have, so Hemdev, just I am asking you to put your chat, because if you raise the hand now, then we may uh, leave our focus. So, okay, yes, thank you. Now we will go ahead with some experience of problem solving. Okay, here there will be a question, then we will discuss. I may give you the tools how which are useful over there. Okay, so this is a question included that is the pre-RMO 2018 problem. Okay. Yeah, I consider that you are writing the question. I insist students to write thoroughly. At least for first 1000 such level questions, you need to solve step by step, showing every details. And after or from 1000 first question, you are allowed to take some shortcuts, not from the first question. Okay, but 1000 questions of such kind. Okay, not our regular or stereotype questions. Hmm. I will read a problem. Let ABCD be a trapezium in which AB is parallel to CD. AD is perpendicular to AB. And suppose ABCD has an incircle which touches AB at Q and CD at P. Given that PC is 36, QB is 49, and now we need to solve PQ. Okay. We need to find out PQ. Now here, which topics are included? First of all, we should understand what is the incircle of a quadrilateral, which touches all sides. So suppose it is a circle. Because QB is greater, I came to know that here AB is greater. Okay, like this suppose. It is said that AD is perpendicular to AB and AB parallel CD. The meaning of that, there is 90-degree like this. Now it is said that in circle touches AB at Q. So this should be Q and CD at P. So this is P. And then therefore we have here like here B, here is C, here is D. Now it is known that the incircle touches, that is the radius is perpendicular. Then therefore here PQ is perpendicular to AB. See the conclusions. What uh, things we are using? I may consider the audience as suppose somebody is not knowing what is going on. For them, there are some questions in their mind. What questions are there? Many times we have a question, what is a trapezium? Oh, yeah. Trapezium is such a quadrilateral in which exactly one pair of opposite sides is parallel. Okay, so here we came to know that what is trapezium. It is that the one pair of opposite sides is parallel. Because AD perpendicular AB is given, we get that angle BAD is equal to angle ADC, that is 90 degree. Furthermore, if I consider that the in circle also touches AD, that the in circle touches, say, AD in R and BC in S. Now we should note that the circle the in circle touches, or the circle touches. Touches means what? There is exactly one point common between the line and that circle. What does it mean? Therefore, we can say that all sides are tangent to the circle. Tangent is such a line which touches the circle. Tangent is such a line which touches the circle. So in short, I can say that you must know about the trapezium. You must know about the tangents, and then some numeracy. We know that the tangent segments drawn from, I may write over here, the tangent segments drawn from the exterior point of a circle are equal. They have equal lengths. And because of this, we can say that QB equal to BS, sorry. QB equal to BS is 39, and it is said that PC equal to SC is 36. So it is clear that this length is 36, this length is 36, this length is 49, and this length is 49. I am not going to write over there because we will draw, suppose, CE perpendicular to AB. Draw CE perpendicular to AB at E. So it means that, so here clearly quadrilateral PCEQ is a rectangle. And then therefore PQ equal to EC. Now here one thing should be noted, that I directly claim that PQ is a straight line and parallel to AD. Then question comes, why? It is just because suppose I is the center, then from I we are dropping perpendiculars to parallel lines, and then therefore QIP is a straight line. Okay? Because that QE and PC are equal, so we get PC equal to QE, which is 36, and then therefore we get BE as QB minus QE. Okay? BE is nothing but QB minus QE. What is QB? QB is nothing but 49. What is QE? Nothing but 36. Is equal to 13. Now look at the triangle, right triangle. CEB by Pythagoras theorem. Yeah, obviously BC we can find out. The total length of BC is 85. Now here again one thing that if you know the Pythagorean triplet, it will save the time. If you know the Pythagorean triplet, you can save the time. And you not have to worry. Suppose you don't know Pythagorean triplet, then we may have some technique. So I will go here CB. Then we have to find out actually CE square, which I can write as BC square minus BE square, which is nothing but 85 square minus 13 square. Don't waste our time in calculating 85 square. It can be said as 85 plus 13 multiplied by 85 minus 13. 85 plus 13 is nothing but 98 and 85 minus 13 is nothing but 72. So it is nothing but, yeah, and now we can find out the square root of CE. What CE is nothing but PQ, and so we can find out the length PQ. Okay, so let's have what the answer comes. Can I turn the slide? We can go back, no, come back, no worry. So we have CE square is nothing but 49 times 2 multiplied by 36 times 2, which is nothing but 2 square times 6 square times 7 square. And hence CE is nothing but 2 times 6 times 7, which is 84. Yeah, I wonder whether I am correct or not. I don't know. Okay, because see, I just put the questions. I am not knowing what method we can apply. I just merely put, okay, yeah, this is possible, that is possible. Now, through this question, what we should understand, the understanding is nothing but we should have the basic ideas, then correct terminology, also correlations, also recalling. See, other than what we know the stuff, suppose I have a list of 300 theorems in geometry. In every detail, those theorems are described, and also the exact proofs are also given. And I have printouts of that. So I am very much satisfied. And suppose one problem appears in front of me, then I am just trying to recollect which theorem to be applied, which theorem to be applied, which. Out of 300, I am just judging up this and no. It will take a long time. So even if theorems are in front of us, we are unable to immediately understand what we can do. Okay, we can immediately understand what can we do. But the and therefore, I always say that initially you need to attempt, initially we need to attempt 1,000 questions with every detail. And then after that, you can try to take the shot. So for geometry, I always say that you need to understand the figure also. And not only figure, you should also know that it is not necessary you should draw the figure by using all tools. You should be able to visualize by drawing a rough sketch. Okay. See, many times we can use the coordinate geometry or some other tools. Say, for example, suppose we are working with some coordinate geometry, and I know what kinds of, suppose the equation of lines, then family of lines, then also the some typical curves. Then I deal with those all entities by algebra, and I am not focusing on the figure. I usually talk with +1, +2 grade students that while solving the coordinate geometry, are you trying to draw a rough sketch? They said, why? Sir, because we have the equation and we know the conditions and we just manipulate by using some algebraic techniques. But I always insist the students that it's a good tool, but before you should visualize, you should understand what is going on, and figures can speak a lot. Therefore, figures are very, very important. Yes, I consider that you must have understood the problem. If uh, just for simplicity, I am telling you that if you are from grade 6th or 7th, then some of the terms may not be known to you. If you are from, suppose, 8th, 9th grade, then you will be excited to solve, as I have seen the answers coming up. So that's a good sign that you are quite eager to solve the problems. And that passion, that hunger, we should maintain so that we can get the great success. Yes. Now, here is again, I would like to give you a small uh, calculation experience. You have to write the problem. Yes, I leave because already we have stated PQ and C are equal. So here PQ is equal to 84. If anyone has any question, just put in the chat. Okay. You have to immediately chat so that our team will see the chat and note down it. Okay. We can see later. Yes. So here is the problem. You should write the problem. Yes. Now we will read the problem. First of all, that in triangle ABC, AB equal to 34, AC equal to 50, median BE equal to 39. Find the length of altitude AD. Oh, find the length of altitude AD. Okay. Now for this, there are two terms. There are two terms that median and altitude is said. Okay. So we need, first of all, to understand what do we mean by median. Median of a triangle is a line segment joining vertex of a triangle to the midpoint of its opposite side. Like this. Okay. But here we are given with median BE. And now we need to get what is AB. AB is 34 and AC is 50. Okay. It means that AE equal to EC is 25, 25. And furthermore, BE is given 39. Now, what does it mean? BE is 39 and all. Then this is a straightaway problem. Okay. See, when you are solving the problems, you may understand that if the problem is solvable by using a single concept or using two concepts or having more than two concepts involved, theorems involved, or the chain of applications of those theorems or concepts, then the difficulty level may increase. Like in earlier question, just I would like to discuss here again. In earlier problem, if you know the tangent property, if you know the Pythagoras theorem, and you know the incircle property and all, so three things you should know, then you should be able. See, I may miss because here I am considering that I know this. But if somebody is not knowing what is a trapezium, then that is actually a thing for such level exams we should know. But now, presently, currently, if you don't know, then it's okay. So I told you what is the trapezium. But three major facts we have used. Okay. And even if it is a numerical problem, not like RMO question. Now, in this question, we need to first of all know there is a relation among sides of the triangle and the median of the triangle. That is first invented by Apollonius, and then therefore it is known as Apollonius theorem. Okay, so it is known as Apollonius theorem. What is the Apollonius theorem? That is nothing but that suppose in triangle ABC, BE is a median, then AB square plus BC square is equal to 2 multiplied by BE square plus AC square upon 2. Or this AC square upon 2 can be said as twice of A square. Because you just look here, AE is nothing but AC upon 2. So A square will be AC upon 2 the whole square. That is AC square upon 4. And if I make it twice, then it comes AC square upon. Okay. We can prove this, but now it is not our cup of tea to see the proofs and all. Okay. So we have to use. Now, I am not going to give you the exact solution or final solution. I may leave the problem for you because it is a numerical experience. So using this, you can get AC. Using this, find the length of AC. And then by using area relation, we can get the altitude AD because we need to find out altitude AD. We have to find the altitude AD. Okay, so how can we find the altitude AD? Just because of the area relation. So using area relation, get altitude AD. How can I get the area relation? Because by Heron's formula, area is under root S times S minus A times S minus B times S minus C. And also this is area of triangle. I use it as delta now. Also we have area of triangle is half times base times height or altitude. Both are areas we can equate. Both areas can be equated. And then therefore we can have the answer of AD. So it's a lengthy for calculation, but not difficult. Okay. So what we have now here, that S, okay, you have to find out AC and then you can go ahead. See, by calculating, I think you can get AC as 56, if I am not wrong, what I have seen so far. Okay, and then you can find out the altitude. Okay, so here I am not considering the like level all and everything. So those who already know the things, just try to understand that this is an introduction to the geometry problems to some newcomers. Okay, we can we can include the problems, but sometimes what happens, say for example, I want to go for a trek. I like trekking, suppose. Then very first somebody asked me that, hey, you like the trekking? Have you done the trek? I said, no, 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 but I would like to do that. Okay, then come with me. And that person may take me to the Mount Everest and ask me that, hey, you have to wear these all then ice axe and typical that shoes with correct anchors and all. You have to climb over there. You have to carry oxygen and everything and now climb. But I said, sir, but dear, listen, listen. This is my first trek. He said, no, you want to do trek, no? See, Everest is the ultimate trek, no? Final. After that, nothing is there. So you complete this summit. But remember, I am not having that practice. My mind is for, my wish is much more, but I am not having any practice. Then what is the use of that wish? What is the use of that eager? Then I need to start from scratch level, small. I should go first small hills, and then typically I must understand different techniques of climbing and ascending and descending. Not only to go up, also I need to come down, or otherwise I will be there forever. So I must have those techniques. And similarly, if you bring this example to learning process, so learning process is almost like a trek. First, you need to take the small experiences, different techniques, and then you try to understand which weapon or which technique is used in the problem. Like climbing the Mount Everest, I need the ice axe and the typical shoes. But by wearing that whole thing, can I climb a small hill nearby my home? It would be difficult because that spike, literally iron spike shoes, will get skid from the rocks because there is no ice nearby my home. There is a small hill. So that technique is not useful, no. So we need to understand what is going on. And then therefore, I included some primary questions. So if you know such problems, then it's my fault that I didn't include the higher problems. Because see, if you will join AMOTP, we will be there to work. And I always like to deal with AMOTP students so that I can learn step by step. I can improve myself because this subject is very, very vast. It is almost like developing also and already developed also. What already developed? I don't know everything. So every day I try to learn. Therefore, so while I am talking, I expect that you are working on. So AD's answer is going to come. Our friends have put the answer, which is 30. Okay. So for IOQM level, you need to get, so these questions were of IOQM level. Okay. and you need to have the technique of 2, 3 topics or theorems included. Now, I included the next question, which is actually from RMO. You know that RMO exam has 6 questions and 3 hours. We need to write the descriptive answers. For that, very important is you need to be precise and concise. And also you need to think deeply about simple things. These are not my quotes. I got these quotes from, this is a Think Deeply About Simple Things is a quote by Arnold Ross, Professor A. Ross, and also Precise and Concise. He was quite interested in the child education, school education, giving them very advanced stuff, step by step, increasing the advancement. But he always, this is the story of some 5, 6 decades before. Precise and concise. Descriptive answer is not like you are elaborating and writing so much and then stating that, see, I wrote the solution of 3 full scape. That is not required. Here required is precise and concise. And very important that there should be logical balance. If there is no logical balance, then there is no use of the whatever write-up you have done. Okay. So for RMO level, we need to take care of write-ups. Very important. After IOQM, everyone must be aware of the write-up. So here I included long back that old question because I took this question since it is solvable by ninth grade geometry, not beyond that. So I included this. So the newcomer will be saying that, oh, great. And the person who knows the next technique, that person can solve this question in 4 to 5 lines, or otherwise we may need more than that. Because this problem, first of all, you write. While I am talking, you can write. Then we will read the problem. There are very, I think in 2012, 4 question papers were set in Central Regional Maths Olympiad. And in those, very nice kind of questions, almost based on what this question is, were given. Okay.
Hello, sir. Sorry to interrupt. Just a small reminder about the time. You need
Okay.
to.
Yes. It's more than what I have. Okay. Yes, I will wind up. Sure.
Okay.
I must tell you that this question, I may just write that using the midpoints theorem. It is solvable. Or if you know about Menelaus, then also it is solvable. So there are at least 2. Other than that, also some techniques are there, but basically you can use this. This is a great thing that you can uh, apply Menelaus theorem here. And again, this is a very typical thing that you are using midpoints theorem over here. So these 2 techniques you need to resemble. Okay. I'm not going to give the solution. You can just write and be sure that you will think at home. And during the course, obviously, we are going to deal with such problems. Then there is a very simple question in everyone's mind. that why Mathematics Olympiad. And I must clear again, even if it should be cleared before me, but I must tell you that what Maths Olympiad or so-called International Maths Olympiad happening in your school are not the actual what we mean. These are the Olympiads, and what the at international level started in 1959. India started participating since 1989. Why we prepare, or what is the use of this? It is just because of the study of mathematical Olympiad. Our mathematical foundations will get stronger, and also we get the deeper understanding of mathematical concepts. We understand the application of mathematical concepts. We understand correlating the mathematical concepts, and also understand the applications to the branches, knowledge branches other than mathematics. And in your higher studies, that thought process, the understanding of the subject, the analysis power, logical thinking, the narration thinking, all those will be helpful in your future studies. And then, therefore, if you are passionate about mathematics, then it is very much important that you should prepare for mathematical Olympiads. So, thanks to all. I hope I didn't take your more time. Okay, so 45 minutes over. So thank you. And over to Sai.
Hi. Hemdev, do you have a question to Bhamre sir?
Somebody is raising the
What
hand.
is what is the old question that you gave? I'm writing it down now. I was reading it, and then you guys went to the next page.
Okay, I think
Yeah.
if you go to the
The
recording, see for how long the every slide was there, and in that time anyone can write the question.
Yeah, don't
but
worry. We'll try to, don't worry about that. We'll try to share the slides with you also if possible. Um, or if someone wrote it down in the chat, they can share it with you, okay?
okay, but can you just go back a little bit? I am almost done. I just have to write the ratios.
See, yeah. Afterwards, now just a minute. This is just introduction. Okay. If you have some net lag, then it may happen. But according to me, when I keep the slide, then it remains always more than 3 minutes after my last write up. Okay. So you just
Okay.
understand. Now you can get the recording and you can see. Okay. Yes. Next question.
Where is it?
We'll try to share it with you through the WhatsApp group that you're a part of. Okay?
Yeah. I'll ask my mother if I'm a part of.
Yeah.
Yes.
Next
Okay.
question, please.
Are you a part of that WhatsApp group?
Please put off the mic off.
Hello, good evening. I just wanted to ask that I have not received any WhatsApp group link.
Okay,
Or
that's fine. We'll take care of it. You'll
yeah,
receive an email about it, I believe.
yeah. Okay,
I'll
thank you.
check and get back to you about it. Yes,
Thank you.
don't worry. Okay.
Yes.
All right. Thank you so much, Bhamre sir. Also, please stick till the end if you have any more questions. We'll have a session just for question and answer towards the end.
Yes. Yeah. Anyone can put the question in chat if you want. Okay.
Yeah.
Hmm.
Okay. Let's move on to the next part. So far, what all have we talked about? So yesterday we had one talk on computational thinking by Vardhan sir. Then we had, then you guys discussed some combinatorics with Murli sir, yeah? And then today we did some geometry. Um, and then we'll spend some time talking right now about algebra. So in mathematical Olympiads, there are four main topics. One is combinatorics, we have geometry, algebra, and number theory. right? This is broadly the um, partitioning of the topics that's been done. And whereas for informatics, you'll need quite a bit of combinatorics. You'll need some knowledge of geometry, not much. You'll need a good hold of algebra, and you'll need a decent level in number theory as well. There's a good amount of intersection between the two. And computational thinking also is required both for mathematical as well as informatics Olympiads. All right. Let's get into some algebra that's there for math and informatics Olympiads. So there are a lot of things. So I think you guys would have seen some amount of algebra and dealing with variables in school already, right? Um, for math Olympiads, the algebra, that's where you start. You start with the school math, maybe solving linear equations, making linear equations from word problems. That's a very good and strong base. You should have a very good base in algebraic thinking that you get from the school curriculum. But there's two ways. So algebra just purely as a subject and algebraic thinking. So algebraic thinking is something that's very, very important and helpful for any Olympiad that you want to pursue, be it math or informatics. What do I mean by algebraic thinking? I mean, you could still have some algebra that comes up in geometry. Let's say you're given some sides like earlier and you want to figure out something else. So you should be confident about manipulating the variables and basic things like that. But even going beyond that, you should be able to generalize what is there in front of you. So, for example, let's say you solve the problem that you were talking about earlier. Then, how can you generalize that problem? For example, what if instead of whatever sides were there, I think some 84 and something something, what if the sides were 100 and 67? Yeah. So you want to go beyond just the problem and generalize it. That's where this idea or base of algebraic thinking comes in. That's one thing. And then there are some problems, like every problem, then there are some problems which are purely just algebra. They don't like, for example, I have listed down some problems for us to discuss. Like these, you just have a bunch of variables playing around and you're asked to solve the equation, right? And so on and so forth. So those could be some problems. So specifically for IMOTP and AMOTP, usually you'll be discussing algebra with one of our faculties. His name is Dambe sir. So for IMOTP, you'll generally start off with some things like number systems, then basic algebraic identities, then a very important proof technique called proof by induction. Then you'll have some systems of equations, quadratic equations, maybe some complex numbers. Another very important part of algebra that comes up later is polynomials. That's very important as well. Then you will also discuss. You'll also learn about things like arithmetic progressions, geometric progressions, generalization, as I said earlier, and inequalities. So in IMOTP, you will build a very strong base in all of these things. And in the Advanced Math Olympiad training program, you'll build on to these things and go one step further. So you'll maybe in AMOTP, you'll have something like some discussion on functional equations, uh, then some advanced things in polynomials like um, Vieta's rule or some more advanced inequalities like Holders, Jensen's, and so on. Okay. So once you have a good base, then that's what you'll get in the intermediate Math Olympiad training program. You'll build on top of it in the advanced Math Olympiad training program. Um, yeah, the prerequisites again are having a good hold of playing around with variables, and thinking algebraically, meaning you should be able to not feel lost when you see a lot of letters lying around. Okay, that's about that. Let's try these problems. Okay, this one I've taken from Pre-RMO 2017. Um, so maybe we can take a minute or two to think about it. And if you have any idea for how to solve, then you can raise your hand and we can have a discussion. So the question is, we're given five distinct two-digit numbers. They are known to be in geometric progression. What is the geometric progression? Geometric progression is just, let me show you some examples for 1, 2, 4, 8, 16, 32. This is a geometric progression. Or it could be 3, 6, 12, 24, 48 is a geometric progression. Another geometric progression could be something like, let's say, 8, 24, 72, 216, and so on. So what is the pattern here? So how would you define a geometric progression? Yes, Kavinan.
They have a common ratio between the two terms.
Exactly. So over here, the common ratio was just 2. You're multiplying by 2 each time. And over here, it's again 2. Over here, however, it's 3. So you're multiplying by 3 each time to get the new terms. So geometric progression is just a progression in which you multiply by the same constant. And the series or numbers that you get are algebraic progression. Okay. So now what is the question saying? You're given five distinct two-digit numbers that are in a GP. So for example, we could consider this the first GP. What are the five distinct terms that we have? We have 16, 32, 64. Oh, but after that we go to 128. So we only get three of these in a GP. We don't get five. What happens here? We get 3 to the 6 to the 12 to the 24, 48, 96. And then it's going to become three digits. So this is also quite good. We got better than 3. We got 4 over here. Over here we had just 3. Now our goal is to find 5 distinct two-digit numbers that are in a geometric progression. Okay, so how do we find 5 numbers? Let's take a moment to think. Yes, you are given two-digit numbers, so which means that they are all integers. You can't have two-digit non-integers. So the fact that it's two-digit tells you that they are supposed to be integers. So that's a great question. For example, you could surely have a common ratio. So for example, if you look at 27, 18, and then 12, and then 8. So these are also in a geometric progression, right? With the common ratio. The common ratio here is just multiply this by 2 by 3. Then you multiply this by 2 by 3. You multiply this by 2 by 3, and so on. So these are in a geometric progression as well. So it's not necessary that to have a geometric progression, your ratio, it's fine if your ratio is not an integer. It's still, as long as it's the same ratio everywhere, it's fine. Okay. All right. Anvita, do you have a question?
I wanted to discuss my idea.
Okay, go on.
We know that because the numbers are two-digit numbers, the
Mm-hmm.
first term should be greater than equal to 10,
Right.
and the last term, which we can take as a times r to the power 4, should be less than equal to 99.
Right. So let's say the first term is A, and let's say the common ratio
Yes.
is R. So your five terms will be AR, AR squared, AR cube, and AR to the 4. So assuming R is greater than 1, you would have
Uh,
A is at least 10,
yes.
and so then this would be like increasing. So you would have all of these in an increasing way. And then you want the
Yeah.
last number to be at most 99. Fair
Yeah, here I
enough.
would want the r to be between 1 and 2.
Okay, why can't R be greater than 2?
Because if I even consider, 10, then my r will like definitely become a number which is not a two-digit number.
Okay, let's investigate that. So let's say you're saying, let's say what's the smallest A I can get? It's 10. And let's say
Yes.
that my ratio is 2. So the second number will be 10 times 2, which is 20. Then the third one will be 40. And this will be 80. And now I can't do times 2 again. So that's going over our limit.
Yes.
So that tells us that R has to be less than 2. Okay, so now we
Yes.
know that R is some fractional ratio between 1 and 2. Okay, interesting. Let me try to take let me try to ask Arya what he has to say from here. Is that fine? Okay.
Ma'am, I think I found a solution.
Okay. How did you arrive at it?
So what I was thinking is that if it is a fractional ratio,
Mm-hmm.
there'll be a denominator which we'll have to divide again and again. So the
Right. Let's see, let's fully understand what that means. So you're saying that let's say R is some ratio A by B. So what does it mean when okay, maybe not A by B, I'll call it P by Q. I've used A already. So if I have P by Q, it means that whenever I start with A and I multiply by P by Q, I have to divide by this Q, right? And then I will multiply by P by Q again. So I have to divide by this Q and multiply by P. Right?
Hmm.
Okay.
Yeah, so I was thinking that since we have to do the transition 4 times, we will need to have
Mm-hmm.
a number which at least has like some number to the power of 4. So I thought of 3 to the power of 4, 81.
Okay, so what are we saying? What's the most number of times you have to divide? So it's when
Oh,
you're doing A R to the 4, that's when you'll have A times P to the 4 divided by Q to the 4, right? So
yeah.
that's telling you that Q to the 4 has to divide A, right?
So then I thought of 81, 3 to the power of 4, and
Mm-hmm.
I to keep the value above 2 digits, so I thought I can multiply by 2 upon 3.
Right. So you're saying, okay, we could consider 3 to the power 4. And then we start with 81. And then we do something we do something by 3. We
Hmm.
multiply by something by 3 each time.
Okay. And
Hmm.
I thought 2.
But,
I would try 2.
okay, so what happens if we do 1 by 3 as the ratio? We would
So
have 81 times 1 by 3 is
27.
27. But
9.
then we
Sorry.
would end up with 9. That's not too good. We want two-digit numbers.
Then
So
let me tell.
instead, we can try 2 by 3. So
Yeah.
we can start with 81. 81 times 2 by 3.
54.
Yes. And
Then
then,
36.
okay,
24.
okay.
and then 16. So it works.
Nice. Neatly done. Nice job. We can also think about it like this. We can also, instead of starting with 3 to the 4, we can start with 2 to the 4 instead. We can start with 16 and have a ratio that have a ratio that increases things every time with 2 as the denominator. So we could try 3 over 2. We'll get the exact opposite sequence. We'll get 16 times 3 by 2 is 24, times 3 by 2 is 36, times 3 by 2 is 54, and then 81.
Okay.
Are these the only possible solutions? So then now you can try to think more. Are these the only possible solutions? Um, could there be other solutions? For example, could we consider 4 to the 4 and then try to work out, or 5 to the 4 and try to work out? So
But
that's something I'll leave to you guys to think about. Okay. And you guys are right. I received some text chats over chat as well. So the answer is indeed 36. You want to find the middle term, right? So that's
yeah,
36. Right. Okay. Nicely done, Arya, and who spoke up? I forgot. Sorry. Okay. All right. Let's do another one real quick. So this one was a problem. I think this was problem 16 from the Pre-Regional Math Olympiad in 2017. So for that, you don't have to write up your solution or explain your solution. You just have to put in the answer. But for this one, you do have to explain your solution. So let's try to write it down neatly as we go. So you want to find all possible integers a, b, and c such that a squared is bc plus 1 and b squared is ca plus 1. And note that it's given that we want them to be integers, and uh, so they could be 0, they could be negative, or they could be positive. Either is fine. Let's think about it for a bit. Right, I see some good ideas in chat. Yes, you can try that. Okay. So the idea that was given in chat by somebody, you just try to subtract the two equations. What happens when you subtract the two equations? You get a squared minus b squared is bc plus 1 minus ca. It is just c times b minus a, right? And this is a squared plus b squared is just a plus b times a minus b. So one way I can rewrite this, I can keep this as a minus b times a plus b. And instead I can take this to the other side so that I have a 0. So I'll get plus ca minus bc is equal to 0. Which means we have a minus b times a plus b plus c times a minus b is equal to 0. Then we can factor out the a minus b, right? So we get a minus b times a plus b plus c is equal to 0. Is this fine with everyone? Do you need me to repeat any part? Okay. This is quite neat now. So what does it mean? When we have two things that multiply to 0, it automatically tells us that either a minus b is equal to 0 or a plus b plus c is equal to 0. One of these has to hold true. right? Let's try to consider each of these cases. I'll wait. I'll pause for a minute or two. If you have some idea, you can raise your hand and we can have a discussion. Yes, I see a raised hand. Let's see. Anay.
Well, my suggestion is like you consider two cases where either a minus b is equal to 0 or a plus b plus c is equal to 0. Can't we simply
Right.
consider another fact that if both of them are 0, the equation still holds well? So if we take both of them to be 0 in a third case, so that would make it more neat and more useful to go ahead with the problem.
You want to find that's a great point. So you could have one of them equal to 0, or you could have both of them equal to 0. But setting both of them equal to 0 would give you one solution. But we want to inspect and find out all possible solutions that there are, right? And if you think about it, considering case 1 and 2 both, that will be considered as a part of case 1 as well as a part of case 2. So when I'm saying a plus b plus c is 0, I'm not saying a is not equal to b. So when we consider this, this case will still pop up here and it will be solved. But also you can't do and just solve it and say, okay, those are all possible solutions. You could possibly have some solutions where a minus b is 0 and a plus b plus c is not equal to 0. And it's important to find them because the question says find all a, b, c. So you want to find all possible solutions.
No, my suggestion was to find some of them. Like I did not say that both of them combined together gives me all the solutions.
Okay. Yeah, you can find some of them by setting both as 0 as well. That's true. But those are just sub cases of the existing cases. When I say a minus b is 0, I'm not enforcing that a plus b plus c is not 0. So, okay. How do we go about this? So let's start with the one that looks easier. So a minus b equals 0. This tells us that a has to be equal to b, right? What do we know? A squared is bc plus 1. Let me write this again. And b squared is ca plus 1. So if a is equal to b, what do you get? You get a squared is ac plus 1. And this is the same thing. And you want to find all integers such that a squared is ac plus 1. How will you find that? So one way to do it is you can just set a, you can take ac to the other side and you can get a squared minus ac is equal to 1, right? And then you can factorize and have a minus ac, sorry, a into a minus c is equal to 1. So what does this tell us? This tells us that since a and b and c are all integers, either both of them are equal to 1 or both of them are equal to minus 1. So either both are 1 or both are minus 1. So again, we can consider a case. So I'll call it case 1.1. A is equal to a minus c is equal to 1. In that case, c will be equal to 0 and b will also be equal to 1. Second case is when we have both quantities equal to minus 1. In that case, again, c will be equal to 0 and b will be equal to minus 1. Okay, so this has been solved. And if you observe in this case, we have a plus b plus, okay, no, we don't. No. Okay, so this is, are there any other possibilities where we have A into A minus C equal to 1? No, these are the only ways we can have them multiply to 1. Okay. What about the second case? Let's say A plus B plus C is equal to 0. What does that tell us? That what substitution do you want to make from here? Any suggestions? Yes. Apramay.
Hi ma'am, good evening. So
Hmm.
if a plus b plus c is 0, so we can take for something from the first equation that wait 1 second. Yeah, a equals to b, so we can write 2b plus c equals to 0.
No, A is not equal to B this time. That was the other case that we already considered. We now want to consider the case when A plus B plus C is 0. A may or may not equal to B.
Oh, then there's yeah, so either a is equal to minus of b plus c, or b is equal to minus of a plus c, or c is equal to minus of
Okay.
a plus b, or all of them are just zero.
What's Yeah, all of them are just true. That's true. What would you like to try and substitute into one of the equations?
A equals to minus b plus c, whole minus of whole b plus c.
Okay, so we know that A is equal to minus B plus C. So let's try substituting it. So you'll get minus B plus C, the whole squared, is equal to BC plus 1. So it's just A squared is equal to BC plus 1. And this is the same as saying B squared plus 2BC plus C squared is the same as BC plus 1. It tells us that B squared plus BC plus C squared is equal to 1. Okay. How do we go about solving this now? Yes, Kavinan.
So is it like b plus c the whole square is 1, so both b and c have to be 1?
No, B plus C the whole squared is not 1. B plus C the whole squared is BC plus 1, as we saw here.
Oh, right.
That was a good try. Okay. Pramay?
Yeah. We know that a cube minus b cube is just a plus b, sorry, a minus b into a square minus a square plus ab plus b square. So we can just
Okay.
substitute b square plus bc plus c square as what do you say? B cube minus c cube by b minus c. Does that work?
That's an interesting approach. So you get B cube minus C cube by B minus C is equal to 1. Okay. How do you go about finding the values of B and C from here? So you know that B cube minus C cube is
Is
the
equal to
same
b minus
as
c.
B minus C. Okay.
So b into b square minus 1 is equal to c into c square minus 1. It's trying to
B
expand that.
into, okay, interesting.
Yeah.
Any other ideas? Does somebody else and also raise their hand? Anna, I think, did you have the same idea? Hmm.
Oh, I think we can maneuver somehow. So You can try using commutative property. So, like we can
Okay.
assume that b square minus 1 is c and b is c square minus 1.
But that's not necessarily true, right? Because we could have something like 6 times 4 is 8 times 3. So none of
Oh
these are
yeah, that
equal to
also
each
works.
other.
Yeah. Okay.
True.
Yes, so that's
Okay, let's see what Anvita has to say, yeah? Anvita? Yeah.
Yeah, actually, I used a different method and I personally feel it's easy. So, should I share it or do you just want me to
Okay,
give my.
go on.
Okay,
What did
so
you do?
basically,
Hmm.
in the first equation, I just calculated the value of c, which is coming out to be a square minus 1 by b. And in the second one, it's b square minus 1 by a.
Okay. Let's get to that in a bit. Let's try to complete it from here. I thought you had some other way to solve this equation.
Okay, alright. I don't right now.
Let's complete this real quick. Yeah. Okay, so for here, let me just go ahead and tell you what I had in mind. Over here, it's I think somebody in the chat also had a similar idea. Um, it's quite neat. Like it's given that B and C are both integers, right? So you can B be greater than 2? Can B be greater than 1, in fact? Uh, it could be, right? Because you could still cancel for it by using this BC over here. Or could you? So, so the idea is to try and bound some things that are happening here. Can you try to do that? Okay, another nice thing that we can try here is to try to get this side as a sum of squares. Over here right now it's somewhat related to squares, but this term could still be negative, which is sort of what's stopping us from doing what you want to do, right? Like we what we ideally want to argue is okay, b square should not be too big. But then one can say, okay, just make BC negative, and so it'll cancel out and it'll like boil down to one. So we want to try and make this write this as a sum of some squares. So maybe what we can try to do, again we can try to say it's b plus c the whole squared minus bc, but then there's this minus term coming here again, which is kind of annoying. We don't want that. If you observe, we know that b squared plus c squared plus b plus c the whole squared is just twice b squared, twice c squared, and twice bc, which is exactly twice of this. It's just equal to 2. And now we are happy, right? Because we have sum of 3 squares is equal to 2. Now we can argue that, okay, b square cannot be too big because all of these terms are positive. So b squared is at most 1. So b is either 0 or 1. And similarly, c is also either 0 or 1. And now it's just case work from here. So B is either 0 or 1. So you can't argue directly from here, as somebody had suggested in the chat, that B cannot be too big, as you could possibly compensate for it through this BC. But this is a fair game to argue. In fact, here this is something that we use some ideas from inequalities. Here, so for example, one of the most used inequalities is something like this. You know that any square is going to be always at least 0. So I can say that if I have any two numbers a minus b, their squared, a and b, a minus b squared is always going to be 0. So this tells us that a squared plus b squared minus 2ab is always going to be at least 0, non-negative, which tells me that a squared plus b squared is always at least 2ab. And then this forms a very strong base for like every inequality you see basically boils down to this sort of an argument that sum squared is greater equal to 0. Inequalities, as I mentioned earlier, is also a big part of this. Okay. So there was another approach that was going to be discussed. I'll just talk about how you had started it. I think it was Anvita. She wrote C as a squared minus 1 divided by b. But from the second equation, you also get it as b squared minus 1 divided by a. And then you try to complete the solution from here. Okay. So this is just some glimpse of the playing around with variables in algebra that comes up, along with some maybe inequalities and some nice polynomials as well. I'll not spoil too much, so you can hear if these sort of things excite you, then I think you should. Mm, give Olympiads and try a good try. Okay, I think that's my time. Uh, Now um, we'll now move on to the last part of this workshop, which I'm quite excited about. So Murali sir will talk for a bit about the RAM Olympiad training programs. So the training that we provide through our year-long courses, and then we'll open the floor for questions. So if you have any questions, please put them in the chat. Okay, over to you, Murali sir.
Yeah. Thanks, Sai. At RAM, we do. Am I audible?
Yes, so you're audible, and the screen is also visible.
Yeah. So at RAM, we conduct mainly 4 Olympiad training programs. The first one is the Foundation MOTP, which is for grade 6 and 7. And this program is conducted in 3 modules of 2.5 months each. And then the modules are totally independent. You can join any one of them. And it happens throughout the year in the sense that there are 3 offerings of that. And then, in fact, you can see more details about this program when the next module is starting and so on from the RAM website. That's one program. The second one is the Intermediate Mathematical Olympiad Training Program. This is for grades 8 to 12. And this duration is 10 months program. And then for the current year, but is for the next year, IMOTP. The deadline is December 1st, 2025. Before that, you have to register. The program is actually conducted every 2 days in a week. Mostly it is on Wednesdays and Fridays, and night 8 to 9:30. And you can join any of these programs, and then there will also be a lot of assignments, and then there will be teaching assistants who will be conducting tutorials and other things. It's a very active course, and then this will prepare you for IOQM and RMO and over a period of time. And we have scheduled it in such a way that we start from December and end before October or something like that. So we have, because usually the September month is the IOQM. Before that, we will be ending most of these courses, and you may need at least about an hour each day outside these class hours for preparing yourself and then practicing problems and so on. It's a very intensive course, And this will prepare you comprehensively for IOQM and then partially for RM, because we will not be doing many of the proof writing type of problems in this course, because we have to cover a lot more material for IOQM in this one. The next one is much more advanced training program, which is Advanced Olympiad Mathematical Olympiad Training Program. This also runs for 10 months, and then this is for again grade 8 to 12. And is for those students who have already attempted in IMOTP in the previous year, or those who are confident that they will clear RMO. Because the problems which you are going to consider in this advanced MOTP, as Bhamre sir also told you about in his class, in his session, that we will be considering a lot of advanced techniques and then advanced theorems and then problems for which are at the level of INMO, that is Indian National Mathematical Olympiad. This also runs for 10 months, and then this is again the course is on Wednesdays and Fridays, and it is 1.5 hours duration for each day, that is 8 to 9:30. There will be tutorials again, there will be assignments, and then these assignments will be much more, what should I say, slightly more difficult than what you see in RMO. See, as you have guessed already, from the number of students getting selected from IOQM to RMO to INMO, the difficulty level increases gradually, and then it increases perhaps sort of a much more faster phase between RMO and INMO. So we need more training and then more time for this. And then if you are opting for advanced MOTP, you should be willing to spend consistently at least about a couple of hours per day for practicing the problems and practice doing the assignments and then discussing with your fellow peers and all those things. So this is much more advanced training program. I think it's not very difficult in the sense that if you really look at some of the INMO problems in the past, all that requires is that a practice in critical thinking and problem solving aptitudes. If you solve about 500 to 600 problems during the course of the year, definitely you are more or less prepared for INMO. And again, note that this INMO and RMO are both very low scoring exams, depending on which state you are from. Even solving one or two problems in INMO out of the six problems, you will be able to qualify for the next level. Meaning not always, but I think most of the time, and so that's what I'm saying. So again, as I said, this is advanced and this is slightly more intensive program, and it's not difficult to pass, and it's not difficult to practice at this level because most of you are young and most of you already know what is expected of you, and more than that, it's all fun. Problem solving is really fun, and then it's really very nice activity. The other one which we conduct is this Informatics Olympiad training program. This is for Informatics Olympiad. Informatics Olympiad is in two levels. One is ZIO or ZCO, and then the INOI. ZIO, as yesterday Vardhan sir pointed out, that it is not a programming contest. It is most of it is algorithms and then combinatorics and number theory type of thing. And again, there are 4 questions and then 3 hours, and then we are supposed to solve. And ZCO is a programming contest, and you are supposed to write programs in C++. And we prepare you for both ZIO and ZCO. INOA is slightly a different ball game, and then it's much more, you need to know more algorithms and then more practice in programming. So that we will not cover in this informatics course. That's why we don't have an advanced informatics course here. So this course will have 9 months duration, and then every week there are 2 classes, one on Monday and one on Thursday. And here also you need at least about an hour practice every day from your part to master the material which is taught in this course. This is much more fun course than the other math course because most of the material which you will be seeing are within the reach of even the 7th standard students. For example, even though IOQM and RMO require that you should be in either 8th standard or above, Informatics OTP you can attempt from 7th standard or above. So even 7th standard students are eligible to attempt this IOTP, so ZIO and ZCO. So this is slightly less, probably I should say that less strenuous program than the other two. Okay. Apart from that, RAM also conducts several camps. Yesterday, Vinay sir talked about this, some of these camps, like RAM TP, which is a flagship camp for us, and it has been doing for a lot of years. And the duration of the camp is 7 days in May, and then for this year it will be March. It's already over, but for next year it will be around March 7, so on. There's Epsilon, and Epsilon course is again for 2 weeks, and this also is a very exciting course, and then you need to spend a lot of time with peers and then mathematicians and computer scientists and then from internationally acclaimed people and lots of fun in the Epsilon India camp. This math.biz is basically applied math on math in finance, economics, and business. And if we have that kind of aptitude to apply math to the other sections of the science, and you will be welcome to attend this one. This camp is for 11 days and usually it is in June. And AGMNC, it is the All Girls Mathematics Nurture Camp, is only open for girls and women, girl students, and then again grade 7 to 10. And this is a fully online course, and usually it is from December, this year it is from December 27th to sorry, 25th to January 1st. And this actually about 3 or 4 lectures per day, all online. You can just take it from home. And this also lets you discuss and then interact with world-class mathematicians and scientists and then other PhD students and various institutions. So this is another camp which you can try. And some of these camps are free and some of the camps are paid courses. The proofs camp is 4 days in August. This is a very nice camp which discusses how to write proofs, because most of the students when they just see the proof for the first time, probably in geometry, they are at a loss to understand how do you construct these proofs. Any proof should have a strategy to construct and then a logical way of giving your arguments. It's almost like trying to convince somebody else that what you discuss is correct, what you are saying is correct. So this writing proofs is a very important skill you should have for RMO, INMO, and then IMO, and even other uh, competitions like this, like AMC and then AME and so on. So this camp will prepare you for writing proofs, and then this again is a very interesting camp for 4 days. And then this year you can just find out what are the deadlines for application as well as what are the charges and all those things for this kind of camps. So these are the camps and courses which are conducted by ROM, and then many of these courses are online and some of them are physical. And then again you get to see even the physical courses, you get to see a lot of like-minded students and then equally talented, and then you will find a lot of fun. It's not just work alone. There will be a lot of fun, there will be a lot of games, and there will be a lot of discussions. And then it's sort of a very exciting experience. If you have not if you have not been to any such camps in the past, this will be a very wonderful experience for you. Okay, right. So let's go back and yeah, any questions?
Yeah, also just one thing adding on to what you just said. So I started out in RAM as a student in 2018. So that was 6 years ago. And then my first camp that I attended was RAM TP, and it was my first ever math camp as well. And it was so fun that I kept coming back in 2019, then 2020, then 2021, then 2022. And so I've just kept going, like every opportunity I get to attend any sort of face interaction with a lot of kids and students who also have a passion for math is it's really amazing to be in that space and have so many fun discussions. And yeah, so I just wanted to say that as somebody who has attended all of these camps as a student, it's really, really fun. Um, to so starting like really early in the morning to late at night. It's a full
Yeah.
on. I don't know what the adjective is. It's filled with so much learning and amazing interactions and discussions. It's, really nice.
Yeah.
Okay, I think now
And
we can.
Yeah, you may know that, I don't know whether you are already been introduced, and Saee Patil has represented India in IMO and also as well as European Girls Math Olympiad, and
No,
then
no,
one
no. I didn't represent at the IMO. I represented twice at the EGMO. Uh,
AGMO. And most of the
yes.
students who come for the camps refuse to go back. And when the parents come to pick them up on the last day, they said, "Why can't the camp continue forever?" So that's the kind of impression these camps give the students.
I agree.
I would strongly encourage you to try one of these camps once, and then you will find out for yourself that we're not telling any lies here. Okay. Now that we have discussed the problems in algebra, combinatorics, and geometry, and then number theory is what has been missed out. Since I have time for about 10 to 15 minutes, let me just give one teaser problem, which will be in number theory, which you can try now. One second. Where am I? Okay, one second. My screen is mirroring or not. Let me just close this and then do that. This as well. Yeah, so let me check whether I can mirror my screen. It's not coming. So, mirror. Screen sharing. The screen. Somehow it's not working. Let me check in some other way. One second. For that, we still have time, so I'm not going to solve that problem, but I'm going to just give you a teaser, that's all, nothing else. Yeah, this is the problem. Can you see my screen?
Yes.
Yeah, this is the problem which I'm trying to do. That is, I'm not going to solve this problem. So consider 14 numbers, 1 power 4, 2 power 4, 14 power 4. Find the smallest natural number n such that they leave distinct remainders when divided by n. So what will be the smallest number which leaves the distinct remainders by divided by n. So this is a problem from IOQM 2024, a typical and a very simple number theory problem, and you can try out and definitely have fun for finding the solutions and so on. So I won't give you the answer as well. So this doesn't require much of number theory. Okay, very simple arithmetic and so on. That's all is required for this problem. Okay, so you have any questions on what we have done?
Yes, we have some questions in the chat. I'll read it out. For IOTP, can I register if I'm in grade 7 now, but I will graduate to grade 8 in March?
No, to actually the
Yes.
registration for IOQM starts in July, June time frame. If at that time you are in 8th standard, you can still do that.
No. For IOTP, yes. For Informatics Olympiad training program, you can
Can
absolutely
do that. Yeah.
register. So, ZIO, ZCO do not have a lower age limit as the IO, like the Math Olympiads do. So, even
Mhm.
if you are in seventh grade or below, you can totally join, and we would be very happy to have you.
Yeah.
What are the prerequisites for IOTP?
Yeah. Go.
So we will be sharing some,
Mm.
sorry, go on.
Yeah. Go ahead.
Okay, so we will, whatever we assume, for example, we might want you to know some basic C++ syntax, for example. So we'll be sharing any material that we want to assume with you beforehand. So in short, there are no hard prerequisites. Anybody with an interest and the willingness to spend the time is more than welcome to join. Um, I hope that answers your question. Murli, sir, do you have something to add?
Pardon me?
Do you have something to add on to
Yeah,
that?
that's fine. So IOTP actually is a very interesting course, and that I would strong because it has more of maths like combinatorics, number theory, and algebra. And even if you are not interested in taking ZIO per se, I would always urge you to look at the problems from ZIO and then see whether you can practice because it teaches you a lot about algorithmic and then computational thinking as well as mathematical thinking, and you have to use some advanced techniques in combinatorics as well for solving some of the problems. And it's much more fun type of problems than the other ones which you encounter in RMO or even IOQM. So I would definitely wish that you just have a look at ZIO problems from the past years. There are lots of material available on the internet, and definitely you will definitely love them. And then just don't be discouraged if you can't solve them, because most of the problems can be solved by brute force, but it's not that's not the intent at all. So you should find some good algorithm for finding the answer, because most of the ZTO problems ask you to find some answer, integer answer. And that answer, again, if you have a computer at hand, you can always bulldoze using the programming, but that's not the idea in that one. That's why it will teach you a lot about number theory, and then, for instance, number theory, and as well as combinatorics.
Yeah. I wouldn't say it's more fun. So, as somebody who has done both math and informatics, I wouldn't say it would be very hard to call one thing much more fun than the others. But maybe one thing I can say is if you're somebody who likes to, code or like go through the process and write it out for the solution, then informatics is the way to go. If you're somebody who likes more of the proof side, say, then you might like math more than that. But essentially the base of both the things is very strong logical and independent creative thinking is the base for both of them. And
Yeah,
again, as Murli sir also said, the math involved is quite similar in both of them.
that's correct.
The only difference is that the math olympiads require you to have a proof background. You want to be able to write proofs, and for informatics you want to be able to write code.
Yeah.
uh, okay. Sir, this is my first time interaction with Ram. I want to start studying from scratch. Please guide me from which book should I start and which books should I refer to.
Yeah, we will also tell you some of the books which are available in the market, and then at least for combinatorics, we have a list of books similarly for algebra, number theory, as well as from geometry. And again, we will be giving some assignments in the class, and then if you follow the assignments as well as, of course, books are very important, and then studying from the books also is very good, and you should do them. And we will just suggest some of the books as well. It's not almost everybody is starting from scratch, because this maths is slightly different from what you encounter in school, because it is more about problem solving rather than recalling theorems and then applying theorems. It's not a plug and play. It is thinking logically which tool you will use, and then which tool will you have to apply, and then in what order, and so on. So that way it's much more fun to learn. Again, as I said, we will guide you through the process. It's almost like as mentors and coach for you, and we will definitely take your hand and then guide you through the whole entire process. Yes.
Yes. Okay. If you want, there's a list actually available for Math Olympiads at least on the official HBCSC website as well. You can refer to that.
Yeah.
And there's a lot of material available on the official IARCS website as well. So you can do that. Okay, next question. Will you teach data structures and algorithms in C++ plus plus in the IOTP course? Yes. So we will be discussing a lot of data structures and algorithms. That's in fact once the plan is to start with a strong base in the mathematical foundations like combinatorics and number theory, and then we will build on to it with algorithm design and analysis. And we will also be doing a lot of coding in class, as well as you'll also get a lot of coding homeworks that you can work on and check by yourself.
Yeah, yesterday also in
Um,
Vardhan's class, there was a math problem which is about finding the solid integers, and then he used an algorithm. So similarly, we will any math many in ZIO problems, we will use an algorithm. We'll discover the algorithm and then find the solution. So we do teach algorithms, and then in some of the problems, we also need to use the right data structure as well, like trees or something like that. Those things also will be taught in IOTP.
yes. Okay. Next we have how much coding should you know beforehand to do the course? So we don't assume any coding background, as I said earlier. We will share some material with you. So we once we have shared the material with you, we do expect you to go through it and get some basic foundations before we start with the classes. So you should not we don't assume any coding background whatsoever, but and no math knowledge as well. So how much prior math knowledge is required? uh, just school math is as long as you're good with the things that are done in say till 8th or ninth grade, a good proficiency with basic algebra, that should be good enough, I believe.
The official
um
link about which
yeah.
official link you are talking about?
Yeah, I
And
just put it for the HBCSE official
okay, good,
list
good.
of books.
Okay, then.
Can you also put the RAM link for
Yeah, I think one
registration?
of the, I think Ganesh or somebody is there and they can put it up. Yeah.
I'll
Yes.
Yeah.
Okay. Um, Yeah, for both these courses, so for the Informatics Olympiad training program, there'll be Murli sir, Vardhan sir, and I will be interacting with you throughout the year. For the Math Olympiad training programs, as you've already met Bhamre sir, and Murli sir will be there again, of course. And there for algebra and number theory, as I mentioned earlier, we'll have Dr. Shri Prasad Tambe who will also be joining in. And you'll also have occasional help sessions or tutorials on the weekends. Um, there is also an active Discord, student run Discord server of RAM where there's some good discussion that goes on about math as well as other things. So you can join that if you want. I'll put the link in the chat in just a bit. Um, one more thing I want to emphasize is even though there are no actual mathematical or coding prerequisites to keep up with the class, the classes are very fun as well as the assignments. So you should be willing to put in the effort as well. And I think I see that in a lot of you. So
One remember that coding is just like language, learning a language. The more you speak, the better you become. So in coding, it is not that knowing the syntax is important. You should have written so many programs, and then you could have debugged so many programs and then made them correct and so on. So that way, even though coding knowledge is not required. As we go along, we have to practice coding in a very active fashion. That means you have to write more code, and then you have to be able to. You should know how to debug them, how to find mistakes in them, and then how to correct them as well. So that's very important. And as we go along, you become an expert coder. So just like learning a new language is basically the same as learning coding.
Yes, that's very nicely said. Are there any more questions?
Discord server, okay. So if there are no other questions, thank you all, and then hope we will see all of you in our courses. And then, as I said, it's all fun, and then it's also very challenging at the same time. And I enjoy teaching, and I hope you will enjoy learning as well. So that's my final comment.